Good morning. This lesson is day 2 of the first lesson in the new unit, statistical studies. The lesson is called Overview of Purpose, Design, and Studies. The bell ringer is, where in the research cycle does the cycle begin and where does it end? If you remember from yesterday, we discovered the research cycle, which was that 5-part where you have a question, you're going to do some research, you're going to design a study, collect data, you're going to analyze that data, and you'll report on that data. So that's the 5 parts: question, design, collect, analyze, and report. Where does it start? Which one of those parts does it start as? As a matter of fact, it's kind of difficult to understand unless you're in the middle of the research process to know why this is true. But just so you know, there's no place to start. Since the cycle appears to apply in only one direction, but doesn't have a distinct starting point, it can really begin at several points. And we can discuss different ways it does. And it doesn't necessarily end in the sense that the question is answered. It could be that more information needs to be gathered to make a better inference or analyze the data. You may find out that needs to be a better question. Okay, so you get the idea. So the study never really does start somewhere. It can end somewhere and begin again in another location. We can analyze the data and realize that before we report, the data is just totally skewed and we need to rephrase the question or redesign the study so that we get better information. So that's why it doesn't end or start at any one location, but it does go in one direction, and that's important to understand. Okay, so good things. Yesterday, I got to celebrate my daughter's birthday with German chocolate cake, which she loves very much. She's 11 years old. I had a student in one of my classes share a good thing with me, and I thought I'd go ahead and share it. She got the part in the new play here at Rudder High School for, I think it's Your Good Man, Charlie Brown. I believe that's the play. Anyway, she got the part she wanted. I think she got Lucy. Not Lucy. Charlie Brown's little sister, I think, is what the part she got. Anyway, that's a good thing here in school. So let's move on. All right, so let's talk about the question part of the design study. What about the question box? Consider this situation. This unopened bag of chips is half empty. I wonder if it really does contain 28.3 grams like the package says. So this type of informal question of observation is the beginning of many investigations. Informal questions can turn into more formal statements or research questions. For example, you may decide to investigate whether there's a scandal in the potato chip industry by checking the following question. Do Spud potato chips contain an average of 28.3 grams of chips per bag? Okay, so now that you've been introduced to the research cycle process, think of some research questions that you're interested in studying. List at least 3 ideas of research questions and consider the following. I'm not asking you to list them, but just I want you to really take some opportunity here to think about some questions that are they pique your interest, okay? What kind of study or experimental or observational? Remember, we learned in the last lesson the difference between the two. An experimental study is a study in which some treatment is given to a group of the participants, and there's another group of participants that the treatment is not given to. And the results of both are compared to see if there's any change in the results for the people that are treated compared to the people that are not treated. Now, an observational study is simply we observe the habits of people, or we survey people and get their information based on the answers to certain questions, or we may just monitor behavior in some manner, okay? And the best approach to each research question is different for each type of individual study you're doing. If you only have 4 weeks to actually implement a research study, is it possible to study any of your research questions? So for instance, if you want to make a study that's going to be required to make a drug, 4 weeks is not enough time because you have to get the study done and research done in order for it to go in front of the Federal Drug Administration. So that's why pharmaceutical companies try to charge so much money, because it takes so long to study and get things safe for people to use. And then how can you change one of your questions to make it fit in this timeline? So you may come up with a good question, but in order to answer the question correctly, it's going to take a lot longer to answer the question than you have in the time frame you're given to complete the study. So anyway, those are some things to think about when you're making a research question. Suppose you could conduct an investigation of the Spud potato chips and that the mean weight or the average weight of the chips in your sample is 25 grams rather than 28.3. And you see X bar right there. That is a statistical variable we use to describe the mean or the average of a sample that we have measured. And the average sample, or X bar, is equal to 25 grams. By the way, I would write that down. X bar is a variable you will need to know for the test. So X bar is very important to understand. X bar means the mean weight of something you're studying, or the average weight, okay? And when I say average, I mean that it's really mean, okay? Do you think that a difference of 3.3 grams between the actual and advertised weights is large enough that it needs to be reported? And if so, how and where do you report this information to? That's kind of a good question to answer. Okay, in some situations, researchers are even more formal and state hypotheses. Okay, in cases like this, the null hypothesis, or H subscript null, generally states that there is no difference between the true value and the claim value. So the true value is the value that you have measured. So you have found an average or a mean average of some value that you're seeking to discover whether it is the same as the claim value. The null hypothesis says that there is no difference and they are the same. Now, the alternative hypothesis, or H subscript A, states that something is different or incorrect, or that something has changed, so that the claim value is not the same as the true value. Okay, so that's important to understand. It is also very important to understand that these highlighted portions on this slide, the null hypothesis and H subscript null or zero, needs to be understood, and it needs to be able to be defined because that will be on the test. And also the other highlighted words or phrase, alternative hypothesis or H subscript A, that also needs to be known. I'll put these up on the word wall so you can see them in the classroom, okay? Know what they mean. Null hypothesis, no difference between true value and claim value. Alternate hypothesis, something is different between the true value and the claim value, or something has changed between the true value and the claim value. So what are the null and alternative hypothesis for the potato chip example? Okay, so the null hypothesis is that the true mean weight of a bag of Spud's potato chips is 28.3 grams or more. And the alternative hypothesis is the true mean weight of a bag of bags of Spud potato chips is less than 28.3 grams. Okay, we can't just check one bag and make a hypothesis this way. Or we can't make a claim that the claimed weight is less than, or the actual weight or the true mean value is less than the reported value, because one bag is not all the bags compared. The only way to really be truthful is if we have a sample set of every potato chip bag that comes off the line, and that's impossible to do. So statistically, we'll pull a sample or a smaller portion of the whole and check them as they come off to maintain the quantity or the true mean value at a certain amount. And if it doesn't meet the standards, we either adjust the machine so that they get more in there, or we change the value that's on there as the claim value. So there you go. All right, notice that the hypotheses say the true mean weight. This implies that the statements refer to the population of all Spud potato chip bags. Now, population is highlighted because we mean to understand that definition. The population is all of the values of every single bag of Spud potato chips. Or say we're talking about making shotgun shells. The population is all of the shotgun shells ever made by that particular company. Or maybe we're talking about chairs. We're talking about a population of all the chairs made. Maybe we're talking about a dog, a specific type of dog. When we imply true mean weight, we imply that we're talking about all the population of dogs in that particular breed of dog. So it's not just a single bag or even a small sample. It needs to be a large enough sample to give us a generalization about the entire population. So this next statement proves it. When a statistical investigation is conducted, we employ, or generally they employ, a sample that is then used to make a generalization about the population. Notice that in the case, as in many cases, population does not refer to people, but to bags of potato chips. Population means all of the items that we seek to research, and that's what population means here. And it is not only highlighted above so we understand what it means, it's also italicized down here to emphasize that we need to understand what that means. All right, to be concise, researchers often use symbols in place of words. Greek letters are usually used when referring to populations, the entire group being studied from which a sample or samples will be drawn. English letters are used for samples or for smaller portions of the population. The particular items or individuals included in a particular study. For example, when discussing the mean, mu, the Greek letter, the population mean is what it means. The population average. The Greek letter mu, pronounced mu, like when a cat says mew mew, not meow meow, but mew. An X bar is the sample mean. It's pronounced just like it says in the parentheses, X bar. You must understand what these two variables mean. Mu stands for the population mean, the average of the population, or at least a statistical understanding of it. And X bar is the sample mean. That's the average of the sample that was studied, okay? Usually when we study a sample, it's large enough to make a generalization about the entire population. We'll talk about how we do that statistically in a minute. And no worries, we're not going to get into the actual how we do that particular study. All right, so the hypothesis for a study can be stated in words and symbols. When using symbols, you must identify what your symbols represent. So H subscript null, which means the null hypothesis, is that mu is greater than or equal to 28.3 grams. And then we define what mu is, says where mu is the true mean weight of a bag of spud potato chips. And the alternative hypothesis, or H subscript A, is mu is less than 28.3 grams. Notice we don't have to write the definition of mu again because we did it in the null hypothesis. We don't have to write it again in the alternative hypothesis because they're right next to each other. And so you can see what mu stands for. So you can see a direct difference between what they claim, which is the null hypothesis, and what the alternative hypothesis is what we're trying to find out whether or not is true. Most studies, we end up spending a lot of money to find out that the claimed weight is actually true. So, but we have to do it to make sure that we keep companies on their toes. All right, so statistical studies are designed with carefully selected measures that ensure within margins of error that if the sample is well selected and the study is well designed and conducted, the mean or average and other measures of the sample are likely to be similar to the corresponding measures of the population being studied. Sometimes the population is small, such as a high school seniors in a small town. And it could be possible that the sample studied is the entire population. However, it is often that a sample is a much smaller subset of the population, such as a research question that might target the entire population of high school seniors in a state or in the entire nation. It would be impossible or near impossible to actually do a research and get a research question answered for every student that is a senior in the entire nation. That is just near impossible. We're going to miss a school somewhere, or we're going to miss a kid that's absent one day, or something's going to happen, and we're just not going to get an entire population. It's not entirely popular, which we always go with samples so that we can come up with some kind of statistical measure that gives us a good generalization from the sample that helps us generalize the population. So practice writing hypotheses. We want to write them in words and then convert them into symbols. All right. Finally, sketch an outline or simple study design that might help study the hypothesis. So a local pizza shop advertises an average delivery time of 20 minutes or less, but it doesn't offer a guarantee such as a free pizza or something. Now, the last national manager, Sulin, wonders if her employees are fulfilling this claim. So let's look at the null hypothesis. The null hypothesis means that the claim is true. The true mean delivery time is, and their claim is that it is less than 20 minutes. And the true mean delivery time alternatively would be more than 20 minutes. So true mean delivery time would be 20 minutes or less. And true mean delivery time for the alternative hypothesis would be greater than 20 minutes, correct? Let me go back. And if you're going to do it down here with the Greek lettering, the null hypothesis of mu is less than or equal to 20 minutes, where mu is the true mean delivery time. And the alternative hypothesis would be mu is greater than 20 minutes. All right, another example, James believes that his mother's houseplants would grow taller if she watered them with rainwater instead of tap water. All right, so the null hypothesis, or the claim, is that the true mean height of plants is the same with tap water as it is with rainwater. You see that? Now, the alternative would be that the true mean height of plants is greater with rainwater than with tap water. And that's what we're looking for. You're going to do it with the scientific notation or Greek lettering, the null hypothesis would be mu is less than or equal to tap water. The true mean height, which is what of the plants, mu is going to be less than tap water. Watering plants with rainwater would be less than tap water. And alternative hypothesis would be mu is greater than. In other words, what you mean to say is that houseplants watered with rainwater would be greater than or taller than houseplants that or plants that are watered with tap water. So that's kind of it. I know it's confusing. It's kind of hard to write it. I don't remember what was in the book, but I should have probably wrote it here, and I'll probably change that for next year. All right, so not all studies lend themselves to hypothesis writing. For example, Giancarlo is interested in cars, and he might want to collect information about the most popular type of car among teenagers and the most popular color or prices of various models. Now, he wouldn't design a study that tests a hypothesis. He could write a test hypothesis, however, if he wanted to know whether or not the advertising for the gas mileage of a certain model is true. So you see where some studies don't lend themselves to that kind of model. I don't know if you recognize this car, but I recognize it very well. This is what we called a Chevrolet Beretta. It was really popular in the 80s, and they were so poorly made, I don't think anybody owns any of them or any of them still exist. They're pretty cool-looking cars, but they were really poorly made, and they didn't last very long. So recall the potato chip hypothesis. The null hypothesis means mu is greater than or equal to 28.3 grams, where mu is the true mean weight of a bag of spud potato chips. And the alternative is that mu is less than 28.3 grams. What would you do next to determine which of these hypotheses is true? All right, I can go back to that. We could take a sample of the chips that are coming off the line and measure them. And if we do enough sample, say about 100 bags, if the plant makes 100,000 bags of potato chips a day, if we took 100 bags, we're only looking at 1/10,000th of the bags they make. So 1/10,000th is very little, but it's still it's enough of a sample to make a generalization about the entire population. So, all right, let's move on. The following case is an example of either an observational study or an experimental study. Now consider the type and design of each study. How do you know? What is the variable of interest in each case? What are some advantages and disadvantages of each teacher's plan? Describe the treatments, if there are any. Who are the participants? And how was the assignment of treatments accomplished? So Mrs. Johnson teaches American history and wanted to help her students do best on their exams. After failing to find any research on different test formats, she decided to conduct her own research. She flipped a coin for each student in her class. If the coin landed heads up, the student took a multiple choice test. If the coin landed tails up, the student received a fill in the blank test. Afterward, Mrs. Johnson compared the averages for the two test formats. So what type of design study was it? Was it observational or was it experimental? So did we give them any treatment? That's pretty much the litmus test to see if it's experimental. We did give some students one kind of test and other students another kind of test, but really we're just observing to see how they do on both tests. We're not really giving them in a treatment to see if anything changes, okay? Now, you could say that, well, the test is the treatment itself, and if you think about the example from yesterday where they let animals listen to certain kind of music, the stimula is actually the experiment, or the treatment. The stimula of the music. But in this case, it's not stimula. We're not stimulating them to help them or hinder them from doing some task. We're just giving them a different task. So we're looking at observation to see how they perform on the different tests. So it's really an observational study. What are the advantages of the teacher's plan? It's really simple to do. She flipped a coin, and then she gave whoever got that flipped coin, whichever test that flipped coin gave her. Okay? There are no treatments. Like I said, the participants are the students, and how was the assignment of the treatment accomplished? Flipping a coin. All right, world history. Mr. McDonald had a similar concern. He decided, however, to ask his students, and he put a question at the bottom of the exam. Which do you prefer, multiple choice or fill in the blank questions? Afterward, Mr. McDonald tallied the results. This is obviously an observational study, right? Gave them a question and asked them to answer it. They didn't give them any treatment. All right. He was interested in the effects of music on students' performance. At the bottom of the exam, he asked students to circle their favorite type of music. He then computed the averages for students who liked each type of compute. Now, what is this? It's a survey. A survey is an observational study. The advantage is it's very simple for the teacher to conduct, okay? There's no treatments though, right? Participants were the students, and the assignment of the treatment, no, there's no treatment accomplished. It's just they give them questions. Mrs. Knox, senior English class, were working on their term themes. During the second period, she allowed students to listen to their choice of music through earphones while working, but her fourth period class was required to work quietly without music. She averaged the major grade for each class and compared second period's average to fourth period's average. Now, which one do you think this is? First of all, what's the variable of interest in this one? Variable of interest is the student's score on their test, right? Or on their essay, their term, right? The advantage is that she only had to play music in one class. That's really all she had to do. But the treatment was the music itself, right? The participants were both students. You had the students in second period who had the treatment, the students in fourth period who didn't have the treatment. So the second period class were the treatment group, and the fourth period class was a control group. Now, the assignment of the treatment was accomplished just by giving them the option or telling them what they could and could not do. Mr. Paul, guitar teacher, sat at a food court in a mall and made a tally sheet that noted each t-shirt he saw with a musical group illustrated on it. He compiled the results and posted an entry about his blog on the most popular groups. Now, that's a survey. It's monitoring. It's an observational study, but doesn't really determine whether or not people like those groups. It may be that they just went and it was the only shirt they had that was clean. So if you see a preacher wearing Metallica shirt, it may be that one time he liked Metallica, and now that he doesn't, he just didn't have a clean shirt at the time. Okay, well, it doesn't mean he really enjoys their music anymore. And it doesn't truly encapsulate what is popular to that particular person. Could be that they have the shirt, and that's it. So it's not a fair assessment. All right, so a group of participants that the treatment group is being compared to is called the control group. So in other words, they're not getting the treatment. A treatment group is the group that's getting the treatment. A control group does not. That way they can compare to see if there's any difference between people that are treated and people that aren't. So give an example of a treatment, the treatment group, and a control group. And here's an example. The beginning of the year, I had a few classes that I played music for while they took their test. And I had a few other classes that I didn't, and I compared the results. And I found out that the people that had the music played were often more distracted and their grades were lower. So it depends on the music you play. If you play music that people like and enjoy, sometimes it puts them at ease. Sometimes, even though they like it, it distresses them and it makes them lose focus. All right. Researchers are often concerned that participants in a study show improvement simply because they're in a study and not because they are receiving any effective treatment. This is called the placebo effect. A placebo is some kind of treatment you're given that has no noticeable effects at all. So example one, half of the participants in a study for a new headache remedy receive the new pill, while the remaining participants receive a pill containing only inactive ingredients. Participants receiving the inactive pill, which is called a placebo, report that their headaches have been somewhat relieved. These participants believe they were being treated, and because of this belief, they may have affected their perception. Okay, so example two, half the athletes in the study received a new lotion for strained muscles, while the other half received lotion with only inactive ingredients. Both groups report improvement in their muscles. The improvement in example two could be psychological, as in example one. Can you think of any other reason why there might be improvement with people getting lotion? Well, think about it. How do you put lotion on? You massage it in. You massage in a muscle. Even if you're putting lotion on, it may seem to get improvement in that muscle, even though the lotion doesn't have any ingredients. So if they got an ingredient-free lotion, they still get relief because of the massaging motion of the hand. So I'll launch you with this. If you ever wonder why some medicine tastes so good, it's likely because there's much more sugar than effective measures to cure symptoms. All right, so there is a lesson in the Google Classroom. Be sure to go get that done. And in the meantime, be blessed and be a blessing.